Hello, welcome to another episode of Maths with Mikhail. On this particular episode, we are going to look at Wassce 2022 Elective Maths paper, Section B, Part 1, which is the pure mathematics aspects. I've already done a video on the compulsory aspect, that's from question 1 to question 8. So I'll leave the link to those videos in the comment section so that you can check it out. On this episode, we are going to look at the solution to question 9, 10, and 11. Kindly subscribe to the YouTube channel if you have not done so, and share the link to your colleagues so that they can equally benefit from this video. Let's begin. Question 9. The second terms of a geometric progression, GP, is equal to the eighth term of an arithmetic progression, AP. The first terms, common difference, and common ratios are all equal and non-zero. Find the sum of the first 5 terms of the geometric progression. Now, the second term of a geometric progression, you know the formula for the nth term of a GP. That's UN is equal to AR exponent n minus 1. That's the nth term of GP. Now the second term, that's U2, which is the second term, is going to be AR exponent 2 minus 1. And that's going to be AR. So that's for the GP. Now, the question goes ahead to say that it's equal to the eighth term of an arithmetic progression. And you know the formula for the nth term of an arithmetic progression. That's UN is equal to A plus into bracket n minus 1 D. So the eighth term, which is U8, is going to be A plus 8 minus 1 D. And that's A plus 7D. So if the second term is equal to the eighth term, we can say that AR is equal to A plus 7D. So that's the first part. Now the question goes ahead to say that the first term, common difference, and common ratios are all equal and non-zero. So first term is equal to A. Is equal to common difference, which is D, which is also equal to common ratio, and they are all not equal to 0. So if we come back to the expression we have here, in place of the common ratio here, we can substitute A, and we are going to get A multiplying A is equal to A plus 7. Now, common difference is still equal to the first term, so that can also be A. We are going to get A squared is equal to A plus 7A is 8A. We get A squared minus 8A is equal to 0. You can factor A out, and I'll get A minus 8 is equal to 0. A is equal to 0. A minus 8 is also equal to 0. And A is equal to positive 8. Now from the question, it says that the first term, common difference, and common ratio are all equal and non-zero. It means that what we have here, A is equal to 0. We can't get the first term, the common difference, and the common ratio to be all 0. So we reject this. So it means our first term is equal to 8. The question is, find the sum of the first 5 terms of GP. So the sum of the first 5 terms. Sum of GP is A into bracket R exponent n minus 1 all over r minus 1. So find the sum of the first 5 terms. So S5 is going to be A, which is 8. So 8 into brackets, common ratio R is also equal to the A. So 8 exponent 5 minus 1 all over 8 minus 1. So if you punch everything here on the calculator carefully, you are going to get 37.448 as our answer for the sum of the first 5 terms of the GP. So that answers the A part of the question. Now the B says that the sum of the first 11 terms of a linear sequence AP is 165. The sum, so we know Sn to be equal to n over 2a plus n minus 1d. So the sum of the first 11 terms, so S11 is equal to 11 over 2 to bracket 2a plus, so 11 minus 1, 10d. And this is equal to 165. This is equal to 165. So can multiply through by 2. So this times 2, this times 2. And I'm going to get 11 into bracket 2a plus 10d to be equal to 330. I'll multiply through by 11. I'll get 22a plus 110d is equal to 330. From here, I can decide to divide through by 22. And I'm going to get a plus 5d is equal to 15. And this is equation 1. From there, we have if the third term is 9. If the third term is 9, this is not sum. So A3. And we are going to use this formula. A plus to bracket n minus 1d. So A3 is going to be A plus into bracket 3 minus 1d. And this is equal to 9. So that gives us A plus 2d is equal to 9. So we have two equations. This is going to be equation 2. So solving equation 1 and equation 2 simultaneously, we are going to get A plus 5d is equal to 15. A plus 2d is also equal to 9. Equation 1, equation 2. Now if I subtract equation 2 from equation 1, a minus a, that will be 0. I'll get 3d to be equal to 15 minus 9 is 6. I'll divide through by 3, and d is equal to 2. And that answers the I part of the question. So because of space, I have to squeeze this ones here. Now on the II, we are asked to find the first term. So if we have the common difference to be 2, we can substitute that one into any of the equations to find the first term. So I'll take equation 2, which is a plus 2d is equal to 9. I know d to be 2. So a plus 2 into bracket 2 is equal to 9. A plus 4 is equal to 9. And a will be equal to 9 minus 4. A, which is the first term, is equal to 5. And this is the solution for question 9. Please take a second to subscribe to the YouTube channel. Question 10. We are asked to expand 1 over 2 minus x, or exponent 6, in ascending power of x. So there are a lot of ways of doing this. We can use the combination method. We can equally use the Pascal triangle. So for exponent 6, if we use the Pascal triangle, we are going to get the coefficient to be 1, 6, 15, 20, 15, 6, and 1. So this will be the coefficient if you are using the Pascal triangle. So if I compare the question given to a plus x exponent n, if I expand this, I'm going to get a exponent n plus 6 a exponent n minus 1 x. So the exponents reduces as the one for the s increases. So plus 15 a exponent n minus 2 s squared plus 20 a exponent n minus 3 s exponent 3 plus 15 a n minus 4 x exponent 4 plus 6 a n minus 5 x exponent 5 plus the last one 1 times, so I get x exponent 6. So if I compare this expansion to the question given, which is 1 over 2 minus s, or exponent 6. So our a is half, the x is negative s here, and the n is 6. So this is going to be a, which is 1 over 2 exponent 6 plus 6 into bracket 1 over 2 exponent 6 minus 1, and the s is negative s, plus 15 1 over 2 6 minus 2 negative s squared, plus 20 1 over 2 6 minus 3 and negative s exponent 3, plus 15 1 over 2 6 minus 4 and negative s exponent 4, plus 6 1 over 2 6 minus 1 negative s exponent 5, plus negative s exponent 6. From here, we are going to get 1 over 2 exponent 6 plus, I am speeding it because I'm only rewriting the same thing and performing the subtraction for the exponent. One over 2 exponent 6, that's going to be 1 over 64. Now half exponent 5 times 6 times negative s is going to be negative 3 over 16 x. So this will be 15 over 2 exponent 4, 16 x squared. So minus 5 over 2 x exponent 3 plus 15, that's 20 times half exponent 3 times negative s is 5 over 2. So we get 15 over 4 x exponent 4 minus, so half of 6 is 3, so minus 3x exponent 5 plus x exponent 6. So if we expand 1 over 2 minus x exponent 6 in ascending power of x, this is what we get. And this answers the A part of the question. Now the B. Using the result in 10a, find the value of Q for which the coefficient of s squared in the expansion is 0. So for this particular question, we are interested in the coefficient of the s squared. Now the expansion was 1 plus qx multiplying 1 over 2 minus s exponent 6. Now the second term here, which is the 1 over 2 minus 6 exponent 6, is the first question we already solved. And we had this answer. So 1 over 2 minus s exponent 6 give us 1 over 4 minus 3 over 16x plus 15 over 16x minus 5 over 2 x exponent 3, 15 over 4 x exponent 4 minus 3 x exponent 5 plus x exponent 6. So after expanding this was the answer we had. But the question says that we should find the value of Q for which the coefficient of s squared. So we are only interested in the coefficients of the s squared. So looking at this expansion here, only the first 3 terms can possibly give us a coefficient of s squared. So in place of the expansion given, we can rewrite it as 1 plus qx multiplying 1 over 64 minus 3 over 16x plus 15 over 16 s squared. So we replace the first 3 terms there. So let's expand. 1 will multiply everything and we are going to get 1 over 64 minus 3 over 16x plus 15 over 16 x squared. Qx will also multiply everything. We get plus q over 64x minus 3q over 16 x squared. So this x times this x will be x squared plus 15q over 16 x exponent 3. So we are asked to find the value of Q for which the coefficient of s squared is 0. So we are only interested in the coefficient of the s squared. So looking at this expansion, we have 15 over 16 and minus 3q over 16. These are the only coefficients of the s squared. So 15 over 16 s squared minus 3q over 16 s squared. And from the question, the coefficient of the s squared is 0. So if we divide every side by s squared, and this is going to give us 15 over 16 minus 3q over 16. And this is equal to 0. So we will find LCM. LCM is 16. So we are going to get 15 minus 3q over 16 is equal to 0. So the 16 multiply 0, we still get 0. So we are going to get 15 minus 3q is equal to 0. 15 is equal to 3q, we divide by 3, we divide by 3. We conclude that q is equal to 5. So this is the value of q for which the coefficient of the s squared in the expansion is 0. BII. We are asked to find 0.45 exponent 6 and correct to 4 significant figures. So the solution 0.45 exponent 6. Now if you compare this to the A, which was the expansion, it was 1 over 2 minus x exponent 6. Now realize that these two things here are very similar because they have the same exponents. So let's equate the base. So we see that 0.45 is equal to 1 over 2 minus s. And we get s to be equal to 1 over 2 is 0.5. So 0.5 minus 0.45. And we get s to be equal to 0.05. So we can say that 0.45 exponent 6 is the same as 1 over 2 minus 0.05 exponent 6. So what that means is, wherever we see x in the expansion, we substitute 0.05. Now from the A, 1 over 2 minus s exponent 6 give us 1 over minus 3 x exponent 5 plus x exponent 6. Okay. So from here, wherever we see x, we substitute 0.05. Wherever we see x, we substitute 0.05. So we are going to get 1 over 2 minus 0.05 exponent 6. And this is going to be 1 over 64 minus 3 over 16, 0.05 plus 15 over 16, 0.05 squared minus 5 over 2, 0.05 exponent 3 plus 15 over 4, 0.05 exponent 4 minus 3, 0.05 exponent 5, and the last one is plus 0.05 exponent 6. So if you input all this data on the calculator, you are going to get 8.304 times 10 exponent negative 3. So we are asked to leave our answer in 4 significant figures. So this is approximately 0.008304 as our answer. So this answers the question 10. Question 11. The volume of a spherical object increases at a rate of 8 centimeters per second. Find the rate at which the surface area increases when the radius is 4. Now with this particular question, there are things you have to know. If the volume of a spherical object increases, now increases means it is positive for the increase, so the rate is positive. Now it increases at a rate of 8 centimeters per second. The volume increases at a rate, so it is dv over dt, the derivative of the volume, by t is equal to what is given, which is the 8 centimeters per second. Now they are asking us to find the rate at which the surface area increases when the radius is 4. So they are asking us to find the A over the T. So that's what we don't know. Now we know the volume of a spherical object V to be equal to 4 over 3 pi r cube. Now if we differentiate the volume with respect to the radius, we get dv over dr to be equal to, so 3 will multiply 4 over 3, get 3 times 4 over 3 r exponent 3 minus 1. So we get dv over dr to be equal to 4 pi r squared. Now the radius is given in the question to be 4 centimeters. So dv over dr is equal to 4 into bracket pi and 4 squared. So this is 16 times 4, 64. So dv over dr is equal to 64 pi. Okay. So let's continue. We divide both the numerator and the denominator by dt. So we get dv over dt all over dr over dt. So if we take this derivative, we divide both the numerator and the denominator by dt. And everything here is equal to the 64 pi. Now we know dv over dt in the question to be what? 8. So I get 8 over dr over dt to be equal to 64 pi. If I make dr over dt the subject, that's this over 1. If I cross multiply, you get dr over dt to be equal to 8 over 64 pi. And 8 over 64 pi, we get dr over dt to be equal to 1 over 8 pi. Okay, that's the first part. Now, the area, the rate, find the rate at which the surface area. Now, the formula for surface area of a spherical object. So, A is equal to 4 pi r squared. That's the formula. So, if I differentiate this, I get dA over dr. So, we differentiate with respect to r. And this gives us 8 pi r. 8 pi r. So we divide both the numerator and the denominator by dt. So we get dA over dt all over dr over dt. And this is equal to 8 pi r. Now we know dr over dt to be 1 over 8 pi. So let's substitute. dA over dt all over 1 over 8 pi. This is equal to 8 pi r. Now the question is asking us to find the rate at which the surface area. So we want dA over dt. So if you make dA over dt the subject, you are going to get dA over dt to be equal to 8 pi r times dr over dt, which is the 1 over 8 pi. So let me put it there. 1 over 8 pi. So 8 will cancel 8. Pi will cancel pi. We get dA over dt to be equal to r. Now, r was given in the question to be 4 centimeters. So we conclude that dA over dt is equal to 4 centimeters squared per seconds. So this answers the A part of the question. B, we are asked to find the gradient of the curve 3x squared minus 4xy plus y squared. Now, if I have a curve and a tangent line. So a straight line touching the curve at a particular point. We can say that the gradient of the curve is the same as the gradient of the tangent, and this is the same as the derivative of the function, so dy over dx. So the equation of the curve, which is the 3x squared minus 4xy plus 3y squared is equal to 15. Basically, what the question is asking us to do is to find the derivative of this function. So using implicit differentiation, because we don't have y is equal to something, the y is part of the equation here, so we are going to use implicit differentiation. So if I differentiate 3x squared, I get 6x. Now, to differentiate 4xy, I have to use the product rule. So you know that uv all prime is equal to u prime v plus u v prime. So we are going to use the same idea here. We differentiate minus 4x and we hold y. So if we differentiate minus 4x, I get minus 4 and I'll hold the y plus, now I will hold the minus 4x and I'll differentiate y. So this gives me minus 4x. If I differentiate y, I get dy over dx plus, if I differentiate 3y squared, I get 6y dot dy over dx is equal to the differential of a constant 15, it's 0. So let's simplify further. I get 6x minus 4x, so I'm writing the 4x dot dy over dx minus 4y plus 6y dot dy over dx is equal to 0. We want dy over dx, so all terms containing dy over dx should be one side of the equation. So I get minus 4x dot dy over dx. There's another term here, plus 6y dot dy over dx is equal to, so let's send the other terms to the right hand side. So I get 4y minus 6x. If I factor dy over dx out, dy over dx, I'm going to be left with, into bracket, minus 4x plus 6y, and this is equal to 4y minus 6x. So I want dy over dx, so I divide everything by the coefficient of the dy over dx. So this divided by minus 4x plus 6y, minus 4x plus 6y. So I get dy over dx to be equal to 4y minus 6x all over, so let me write the positive first, 6y minus 4x. So the gradient of the curve is given as this, and it occurs at a particular point. So at the point is 2, 3. So wherever I see x, I substitute 2. Wherever I see y, I substitute 3. So dy over dx is equal to 4 into bracket 3 minus 6 into bracket 2 all over 6 into bracket 3 minus 4 into bracket 2. So 12 minus 12, which is 0. 0 over any number is 0. So this is going to be 18. 6 times 3, 18 minus 8. So I get 0 over 10, which is equal to 0. So the gradient of the curve at point 23 is 0. Thanks for watching this video. Please kindly subscribe to my YouTube channel, Maths with Mikel, and share this video, like, comment, and see you in the next one. Thank you.